Let's start with the error object itself, because everything else depends on understanding it, and most people only ever use one field of it. Inside an error handler you get an object called error. Error.description is the readable message, and that is the one you put in a logger. Error.detailed description is the longer form, though very often it is identical, so check before you assume it adds anything. Error.errorType is the classification, and this is the important one, because it is what handler matching uses. It has two parts, a namespace and an identifier. http:/not_found has namespace http and identifier not_found. You can reach each separately with error.errorType.namespace and error.errorType.identifier and join them to build the full name as text. Error.cause is the underlying Java exception. It is useful in a log while you are debugging, but do not branch your logic on it. And that is not my opinion. MuleSoft's own documentation explicitly warns against depending on that internal structure. Then error.errorMessage, and this is the one almost nobody finds. When an HTTP request fails, the backend's actual response, its status code and its BIE, are inside error.errorMessage. Error.errorMessage.attributes.status code gives you the real status. Error.errorMessage.payload gives you what the backend actually said. If you have ever logged an error that just say HTTP get on resource failed and wondered what the other system was complaining about, this is where it was hiding. And finally error.childerrors, a collection of inner errors, which gets populated by aggregating routers like scattergather where several routes can fail at the same time. Now, before we touch a single component, here is the distinction that almost no tutorial makes, and it will save you hours. Not every error in Mule can be handled. They live in separate branches. Everything under any is handleable. That is transformation errors and expression errors from your data weave, connectivity errors, and its child retry exhausted when a remote system is unreachable, routing errors, security errors, with client security and server security underneath, validation errors, including duplicate message, timeouts, stream size exceeded, and unknown for errors Mule cannot classify, which is caught by any for backward compatibility. All of those you can catch. Then there are the branches you cannot. Critical, which includes fatal JVM error and overload, is described in the documentation as so severe that it cannot be handled and is only logged. Source errors happen in the flow's source before your flow BIE ever runs, for example the listener failing to bind its port, so there is no flow execution for a handler to sit inside. And source_response errors happen while sending the response back to the caller after your flow has already succeeded, which is too late to handle. So if you have ever written a handler for one of those and wondered why it never fired, that is your answer. It was never going to. Error types are not a flat list. They are a tree, and understanding that makes your handlers much shorter. Every type can have a parent. The parent of HTTP:/unauthorized is Mule:/client_security, and the parent of that is Mule:/security, which means a single handler on Mule:/security catches HTTP unauthorized, client security, server security and not permitted, all of them, without you listing any of them. Connector errors carry their module's namespace, so http:/not_found db:/query_execution. Runtime errors use an implicit Mule namespace, so when you write expression you are really writing Mule:/expression. Now the rule that catches people out. Handlers are evaluated top to bottom and the first match wins, so specific types go above general ones. If you put in any handler at the top of your error handler, every handler below it is dead code and will never run. And finally, error mapping, which is the most underused feature in Mule error handling. If you have two HTTP requests in one flow, both of them throw HTTP:/connectivity when they fail. Identical error, and you cannot tell which call broke. Map them per operation to app:/orders_down and app:/audit_down, and suddenly your logs and your handlers can tell them apart immediately. Open the Mule palette, scroll past flow control, and there is a category called error handling with exactly 4 components in it. That is the entire vocabulary. Error handler, on error continue, on error propagate, and raise error. Everything else you have ever read about Mule error handling is a combination of these 4, and where you put them. Error handler is the container. On its own it does nothing at all. It is a box that holds blocks. You drop it at the top level of a configuration file to create a named global handler, or Studio creates one implicitly when you add a block to a flow. It never decides behavior. It just holds the things that do. On error continue consumes the error, the block runs, and then the flow is treated as successful from that point on. Whatever payload the block leaves behind becomes the flow's result. If there is a transaction open, It commits. Use it when you can genuinely recover, or when you are deliberately turning a failure into a valid response. onErrorPropagate runs its block and then rethrows the same error to whoever called this flow. The flow is marked as failed. If there is a transaction, it rolls back. Use it when the caller must know, and it is the right default whenever you are not certain, because a failure that propagates is visible, and a failure that is swallowed is not. And raise error is the odd one out. It is not a handler at all. It is a thrower. You put it in normal flow logic to fail deliberately, with a type and a message you chose. It is the component that turns a business rule into a first-class error the rest of your architecture can route on. And here is the same 4 components assembled into a real handler file. A builder pipeline across the top, handler blocks underneath, and raise errors living over in the validation subflow. 4 components, 3 jobs. Keep that picture in your head for the rest of the module. So here is the difference that everything else hangs on. Both components run your handler logic. What differs is what happens the instant your handler finishes. onError continue consumes the error. It stops there. The scope or flow that owned that handler is treated as successful. Execution carries on after it, and the caller gets a success response. Inside a transaction, that means commit. onErrorPropagate does the opposite. It runs your handler, and then rethrows the error so it keeps traveling upward. The scope or flow that owned it is treated as failed, and the caller gets an error response. Inside a transaction, that means rollback. And there is one more thing worth knowing. Propagate is effectively the default behavior. If you write no handler at all, an error propagates upward on its own. Continue is the one you have to ask for. Now, how do you decide which one? There is a single question that answers it every time. Ask yourself, should the customer's request still count as successful if this particular step failed? If the answer is yes, use continue. If the answer is no, use propagate. And notice that is a business question, not a technical one. Whether a failed audit log should fail a customer's order is not something the framework can tell you. Let us configure one properly. This is the error handling section belonging to the try scope. Selected, and the properties panel below is now showing everything and onError continue can be configured with. There are only 4 settings, and 2 of them are the ones people get wrong. Field 1, display name, technically optional. In practice, never leave it as the default. Look at what this one says. Audit failure is non-fatal. That sentence tells the next engineer why this handler exists, and it is printed on the canvas so they read it without clicking. Name the handler after the decision, not after the component. Field 2, type. This one is set to A. Leaving it empty means the same thing. And here is the trap. Any sounds like everything, and it is not. Any matches every error underneath Mule (any in the hierarchy, which is all the normal messaging errors, connectivity, expression, security, your own app errors. It does not match critical errors, it does not match source errors, and it does not match errors thrown while writing the response. Any means every error you are allowed to handle, not every error that exists. And you do not have to type the type by hand. Click the field and Studio lists the actual error types available in this project. HTTP:/BAD request, HTTP:/connectivity, HTTP:/timeout, HTTP:/unauthorized, and the rest. These come from the connectors you have added, so the list is real, not a guess. Pick from it and you cannot typo a type name, which is a failure mode that produces a handler that silently never runs. Field 3, when. Optional and the most powerful field on the component. It takes a Boolean expression, and the rule is, the block runs only if the type matches and the when expression is true. That is how you write one handler for 4xx and another for 5xx, while both for type any the condition, not the type, does the routing. We will see exactly that in the global handler in a few minutes. And the last 2 checkboxes. Enable notifications is on by default and feeds the Mule notification system. Leave it. Log exception is the interesting one, and here it is deliberately unchecked. Log exception dumps the raw stack trace to the console. Since this handler already logs a clean, structured line with a type and the correlation ID, turning it on would give you the same failure twice. Once useful, once is 40 lines of noise. Turn it off when you log properly. Leave it on when you have not written a logger yet. 1 repetition, because it is the single most common bug in this pattern. After onError continue runs, the payload is whatever the block left behind. It is not automatically your original data. That is why there is a set payload here reading vars.order response default payload. Save what you need into a variable before the risky step, and restore it in the handler. If you skip this, your flow succeeds while carrying an error object as its payload.